So for number 42, we want to see if this sequence here converges. And now a sequence an converges if it tends to a specific limit, that is a defined number, as n approaches infinity. So let's take this limit as n approaches infinity and see if it spits out a defined number. So we're going to take the limit as n approaches infinity of ln n plus 1 minus ln of n. So if we just take this limit directly, we're going to get ln of infinity plus 1 minus ln of infinity. Infinity minus infinity, we don't know what to do with that, right? Because that's not a defined operation. So what we're going to do here is we're going to change this into a quotient so that it's easier to deal with, because we like quotients whenever we're dealing with infinity. And so we're just going to use this law over here that log of a over b is equal to log of a minus log of b. And so if we compare this, we're going to see here that we're just going to reverse engineer this, right? We're going to say, okay, we have ln of n plus 1 minus ln of n. So this means that the original, or not the original, but rather the transformed version must be ln, 1 minus the other, so a goes on top, n plus 1 divided by n. And we can see that these are equivalent, so we're going to say this is the limit as n approaches infinity of ln of n plus 1 divided by n. And now I'm just going to break up this argument so that it's easier to evaluate. So the limit as n approaches infinity of ln n of n divided by n plus 1 over n, which is the limit as n approaches infinity of ln of 1 plus 1 over n. And so let's see what this limit here is. The limit as of ln of 1 is just 1 plus 1 over n. Well, 1 divided by infinity, that is going to tend to 0 whenever we have a limited number, right, that's not infinity, and we divide it by an infinitely large number, that is going to get us to 0. So this is the same thing as ln of 1 plus this limit here is 0, which is ln of 1, which is equal to 0. So we can see here that our limit is 0, right? So we can say that an tends to 0 as n approaches infinity, where 0 is our limit, so an converges. And that is our conclusion right here.